Hello everyone, welcome to the GATE and PTL lecture course. Today we are going to solve some GATE problems. Consider a system of three charges minus q by 2, minus q by 2 and q. And we have to find what is the electric dipole potential in volts at any point r comma theta. So here these two charges minus q by 2 and minus q by 2 and they are placed at a distance 2d. So the total combinations minus q by 2 minus q by 2, they will form a complete charge combination of charge q placed at a distance d. And similarly, you have a charge q placed at a distance d. So this kind of combination then make a figure very much like electric dipole moment. We have to find electric potential. So we have given the distance r. It is given to be 10 meter. We have given theta. It is 60 degree. And we have given the charge q, which is 10 raised to power minus 6 coulomb, and the distance d, which is 10 raised to power minus 3 meter. So we have to find the electric potentials. So best way to solve the problem is just to check whether it is making an electric dipole moment or not. For example, and the best way to calculate is for the case of monopole, as I have told you, we have just combine is depend upon summation over charge q. So we have to see the summation of all the charges. So we have three charges. Q1 is minus q by 2, Q2 is minus q by 2, and Q3 is q. So we have given three charges here. So we just take the sum of them, summation over all these charges. We are getting minus q by 2 minus q by 2 plus q. So this will become 0. So there is no monopole here. So electric, so we will check it is the case of dipole or not. And to check the case if it is the dipole or not, it is directly proportional to the qi di. So we have to calculate the distance as well. So our charge minus q by 2, it is placed at a distance d in the y direction, which is negative. So it is q into t, but negative y direction. Then there is another charge minus q by 2, which is plus d direction. So there is a charge minus q by 2 to d, which is plus y direction. And there is another charge q, which is in z direction at a distance d. So we have plus q charge into d in the z gap direction. So in this case, our dipole is minus q p by 2. In the y cap direction, it is plus minus q by 2 d phi cap plus q d z cap. This quantity will cancel out. So we have a finite value of electric dipole. So the potential that we are going to calculate is due to the electric dipole. And the potential we have calculated is p cos theta upon 4 pi epsilon naught in the r cube direction. Not the direction, it's a scalar quantity. So we are given p, which is q into d. Q is given 10 raised to power minus 6 coulomb. D is given 10 raised to power minus 3. Theta is given 60. So we put all these quantities here and the potential V is then calculated as 10 raised to power 9 Q T cos 60 divided by R cube 10 meters cube. So if you calculate this quantity, you can try yourself. This will turn out to be 0.045. So the potential that is going to be came here is 0.045.